Alright guys, today we're going to be talking about stereochemistry, and whenever we come across stereochemistry, we come across words like chiral center, chirality, chiral molecules, and achiral molecules. So what's a chiral center? It's a tetrahedral atom and has four different substituents. And chirality is pretty much a structural characteristic of a molecule that makes it impossible to superimpose it on its mirror image. And a chiral molecule um, is fulfilled when it's not identical to its mirror image and cannot be placed on its enantiomer and has no plane of symmetry. All of these versus a chiral molecule. Um, it's pretty much a chiral molecule is not chiral and has plane of symmetry. Plane of symmetry. All right, let's go over a few examples. To begin with, um, let's look at this molecule. The center atom is carbon, and it definitely has four different substituents, like this CH3 group, fluorine, bromine, and hydrogen. And it does has a and it's a tetrahedral atom because it is sp3 hybridized. So this definitely fulfills a chiral center. So let's see if this is a fulfills the chirality aspect. So pretty much the chirality says that a molecule that make it impossible to superimpose it on its mirror image. So this molecule, so its mirror image should be not superimposed on it. So for example, if I were to draw a mirror in the middle here and draw its mirror image here, this is how it would look like. So this fluorine will come out from here, will show here. The bromine will still come out of the plane. So the bromine's here. This hydrogen's actually going to be in the back. Its mirror image is going to be in the back over here. And this CH3 group will be still in the plane here. So chirality pretty much says that if I were to take this molecule and place it over this, in order to fulfill chirality, it should not superimpose it. So if I were to do that, if I were to take this molecule and superimpose it over this, my fluorine will actually impose over this hydrogen. My bromine will still impose over this bromine. And you can see this hydrogen on the right will come out here, and the CH3 group will be here. So actually it does pass the test for chirality. So this molecule is a chiral molecule. Um, when we talk about stereochemistry, we also talk about R and S configuration. So let me quickly go over that. The R and S configuration. Pretty much the R and S configuration gives us direction, um, is related to direction. So the R pretty much um, relates to the clockwise direction. So this type of direction, and the S is the counterclockwise direction, which should give this type of direction. So and in order to find the RNS configuration, we need to look at the substituents of the tetrahedral center, um, the substituents that are attached to the center atom. For example, here we're looking at this carbon, and the numbers, the way we give numbers is the um, the lowest numbers goes to the atoms that have the highest atomic number. So for example, here bromine gets number 1, and then fluorine because of its atomic number, carbon 3, and then the lowest atomic number goes um, the last number 4 goes to the lowest atomic number, which here we have 4. So so what is this molecule? Which configuration does this molecule give us? So pretty much what we do is draw an arrow here like this from 1 to 3, connecting 1, 2, 3 pretty much. And this looks like it's giving us a counterclockwise direction. Uh, actually, yeah, counterclockwise direction, which gives us a S configuration. So one cool thing um, we can talk about here is the mirror image of this molecule. Why it's cool is because the mirror image actually should give us the opposite direction. So let's see if this is true. So let's number again. So my bromine gets number 1 because it has the highest atomic number, and then fluorine, carbon, and then my hydrogen, which gets number 4. And to make it easier, I'm just gonna draw it here on the side. 1, 2, 3, 4. And it looks like this is giving me this direction, which is the R configuration, and it's clockwise direction. So yeah, this is R and this is S configuration. All right, cool. Let's do a couple other problems here. Let's see if these molecules pass the chiral um, test or if they are achiral. Let's look at this one. Um, it looks like we have two chiral centers here, this carbon and this carbon, and they both have 4 different substituents attached to it. Right away, this passes the chiral center test, but it does not pass the chiral test, molecule test, because as you can see here, if I were to draw a straight line in the middle, this side is similar to this side, so this has a plane of symmetry which goes under achiral. So this is achiral. Achiral. Let's look at the molecule right below it. Looks like it's almost similar molecule, but um, the um, the directions of these atoms in space are different. So here the fluorines going out of page, and on this one, on this carbon here, the fluorines coming towards us out of the page. So, and they're both again um, uh, pass the chiral center test. But if I were to draw a line in the middle, this actually is not symmetric. Why? Because as you can see that this fluorine is going into the page, and this fluorine is coming out of the page. So this has no plane of symmetry, and it does pass the chirality test. So this is chiral molecule. Also, we can do the RNS configuration on this one and this one as well. But let's go with the bottom one. Um, so let me number these carbons: 1, 2, 3, 4. So carbon number 2 configuration. Let's find that. So fluorine gets number 1, and then let me change my colors to blue. So fluorine gets number 1 because it has the highest atomic number, and then this carbon number 3 gets number 2, and then this CH3 group in the bottom here gets the 3, and 4 goes to the hydrogen. Usually hydrogen is the lowest because it has the lowest atomic number in the periodic table. So if I were to make it simpler and put it right here, 1, 2, 3, 4, it looks like it's giving me this type of direction, which is a clockwise, but um, when it comes to RNS configuration, I didn't go over this. The hydrogen needs to be the direction of the hydrogen needs to be going into the page and not out of the page. So when it's coming out of the page, you pretty much, so if this is R, you change it into an S. So this is actually this is its original direction, counterclockwise. All right, let's do one for the carbon. So carbon number 2. So carbon number 2 is R, and let me change my pen to orange. Let's do carbon number 3 here. It's configuration. So fluorine gets 1. Um, let me change that to a different color, like green. Fluorine gets 1, and this carbon number 2 gets 2, 3, and 4 goes to this hydrogen. If I were to make it a little simpler, draw it here, 1, 2, 3, 4, 1, 2, 3, and then 4 is in the back. You can see it's giving me this type of direction, which is counterclockwise, and my hydrogen's going in the page. So this is a S configuration, so I don't have to change it because my lowest atomic number is in the back um, going into the page. So yeah, carbon number 2 is carbon number 3 is S, so I would just say to R. Let me just change that color. So 2R and 3S. This is the configuration for this molecule. All right, let's check for chirality with these two molecules here. Right away, you can see that this molecule here has a plane of symmetry, right? If I were to draw a line right there, you can see that plane of symmetry is reflected on the top and the bottom. So this is a chiral molecule. And here we're focused on this carbon. And right away we can see that this does not pass the center, chiral center, because there's similar substituents. So this is achiral as well.